So let's do one more problem. And down here we have the function f. So we're going to follow the same strategy as before. And we're first going to set f of x equal to y so that we can switch x and y. So we have minus 2x plus 2 over x plus 7. And now we're going to switch. So we can say this is our inversion process. We are inverting the function. So we get x is minus 2y plus 2, all divided by y plus 7. And let's solve for y. We're going to multiply each side of this equation by y plus 7 to cancel out that denominator so that we can get y in the numerator. So we get x times y plus 7 is minus 2y plus 2. Since these are going to cancel each other out, something divided by itself is always equal to 1. And let's distribute now so that we can get y out of the parentheses. So we get xy plus 7x is equal to minus 2y plus 2. And let's move all the y terms to one side. So we are going to, let's say, add 2y to each side. So we get xy plus 2y. And let's also subtract 7y on each, or 7x on each side so that we can move all the non-y terms to the other side. So this will be equal to 2 minus 7x. And notice we have y on the same side, but we can't combine them with addition since we don't know what x is. So let's factor y out. And we'd be left with an x here and a plus 2 here. And we still have 2 minus 7x on the other side. And our last step to get y by itself, let's just divide everything by x plus 2. So y is 2 minus 7x over x plus 2, and this should be our inverse function, f inverse of x. And since we checked the last one by hand, let's check this with the calculator. So we'll get our graphing calculator out, and we need to type in both of our functions. So let me first type in our original function. So that's going to be our minus 2x plus 2, all divided by x plus 7. Make sure you are using parentheses here. That is incredibly important. The calculator reads the order of operations exactly how you put it. So we want to say that the expression in the top, the entire thing, is divided by the entire thing in the bottom. And so you need parentheses to say that. Now we do want to keep our line y equals x since we're going to look for that symmetry across that line. And let's plug in our inverse function. So again, use parentheses. We have this 2 minus 7x, close parentheses, divided by x plus 2, all in parentheses. And if we did it correctly, we should get a mirror image about this red line, y equals x. So this one, let's zoom out a little bit. We'll hit zoom 3. And I'd like to zoom out closer to the center of this. So I'm going to scroll down a little and scroll over. Let me just move up a little bit more here. But it does seem like we do have symmetry here. And now you can see it much better. So this black line is a little bit cut off with all the dash marks, but you can see this mirror image on either side of the line y equals x, this red line. So you can visually see the symmetry, but we can also check by looking at a point. On this blue curve, let's just plug in 1 or any value you want, and we get a y value of 0. And so now we're going to go to our black curve and plug in 0, and hopefully we get back 1. And if we get back 1, that means that it is correctly switching the x and the y values between the two functions, which means they are in fact inverse functions of each other. So checking with the calculator worked, which means that we can feel very confident that this is in fact the correct answer, and we can put it into our box here.